That's good. Okay, so in assignment 2, you kind of reviewed all these things. I haven't, I have only done some partial input corrections and so on. So I'm going to do that, take care of that tonight before, before morning, right? So in the sense that it will be there before morning you come back, from your sleep. So I will provide input for your assignment 2, okay, point 1. The second point is I sent an email to all of you in an announcement regarding I sent an announcement regarding assignment 3, sections and subsections. I have a link in that one, in the message, which gives you the document on how to follow those directions. Okay, so I'm going to share my screen. I don't think now I'm sharing yet. Okay, click start sharing. So you are able to see my screen now. Am I right? Just give me some input. Okay.
Yes, we can see it.
Thank you. Thank you very much. All right. So, so this is what it is. Are you able to see enough of the screen, or I need to make it bigger? Maybe now it's better, right? Okay. All right. So let me open that document, whatever I sent you. Okay. This is the document I sent you. So in the earlier document, what we did is the following, right? We recalled the design thinking, because that is what is going to give you how to design the data capture process. Okay, oftentimes you may not have data. Sometimes, many times, maybe, I shouldn't say oftentimes. Sometimes you may not even have data. You may not even know the questions that need to be answered. So I take you through a full life cycle of a project, analytics project. But sometimes life could be much easier. You are given, beautiful, well-arranged data for yourself to do your algorithm. So it's probably 2 weeks' time of work or 3 weeks' time of work maximum. But that is not the case when you are doing innovations. Whether it is product innovations or services innovations, you have to understand your customers, empathize their needs, define, a certain point of view that's based on their needs and insights, create the insights, ideate what you need to develop as solutions, and build a representation of one or more of your ideas to show it to others and test and go through this cycle. Now, up to this seems to be, analytic solutions. So what does this mean? Build one or more ideas to show to others. This is really about analytical strategies. So sometimes you have to think about 2 different ways or 3 different ways, and then nail it and saying that, no, this is the pathway I'm going to take to develop your analytic solutions. And then, of course, you have to verify whether the solution works or not, and sometimes you may have to go back and recycle here, in these 3 areas. Now, so this is design thinking that is, in some sense, is adapted to analytic solutions development. That's how, I see the world. That's how practitioners use it. Last time one student asked me, Dr. Sam, I did in the research in the internet, and I never saw anybody talking about design thinking being used for analytics and also data strategy, all those things. Where did you get these ideas? I said, look, you may not know, not everybody who practice it are going to be publishing it. Okay, so these are the things that people use it, in organizations which are trying to innovate, create new products and new solutions, service solutions or products. But also, even for analytic solutions, this process works. So that's how I brought these ideas together to you also. And, using these ideas, design thinking, you know how to design the process of carrying through from your needs, and that is the KPI or key performance indicator or key lead indicator through a process of a solution development. Okay. So we talked about in the process, this is the process in general developing the solution, but also it helps you to define the KPI. In the process, actually, you will know when you are going through this process, you will know what the KPI is. Okay. So KPI refers to the measurement that, the central measurement that you are trying to capture and create insights and apply them for your products and services. In the same way, here KPI refers to your the key measurement that you are going to model, whether it is the classification or regression. The whole world is about classification and regression. Okay, that's how the whole modeling can be categorized. Whatever the type of model it is, whether it is generalized linear models or neural network models. Now, I'm not talking about things like image recognition and audio recognition and so on. That is the classification model. In general, I'm saying the world of statistical learning, where we have generalized linear models, regression models, classification models, multinomial classification models, and so on. So in the process, you figured out using the issue tree, you figured out the what data you need to ask for. You develop the data strategy, and through that process, you created the requirements for asking for. You created requirements for getting data. Okay, and they provide the data. You actually negotiate also, because in the process of asking for data, you might not get some of them. So there is a negotiation that goes on with your management, with your team, or with the third-party vendor, whatever it is, who is creating data for you, and then you work with what the data are provided to you, what data are provided to you. So when the data comes in, then you do the QA, data audit report. That is, whether whatever the data you are getting actually is having quality or not. And I defined that, kind of technically, I said there are 10 steps to, data quality management. So statisticians 10 steps for data quality management. This is actually the last assignment notes. I'm just reviewing quickly. And in the process, you will establish the data quality, and then what happens? Now you are ready to talk about statistical measurements. We talked about KPI, we talked about data strategies, and what also called the issue tree, all those things. Now we come to the statistical measurements. These are the measurements that tells you whether your dependent variable is going to increase, for changes in the independent variable, and in what direction they will go. And I asked you to create some kind of a tabulations like this, because you need to commit to this kind of hypothesis. That's why the hypothesis come into play here into the model. So, for example, in this case, I'm saying variable 24. I may have hundreds of variables and coded as 1, 2, 3, 4, and so on. Using database, I created age. The original data was database, but I created age, and it's a derived variable. It's we say it's positively correlated to the dependent variable, and so on. Age square, it is negatively correlated to the dependent variable, and so on. So I asked you to complete this one, and then you are working on variable reduction, because now it may have hundreds and hundreds of variable potentially. Okay, I used to work with 1,000+ variables commonly in my consulting job. Now you are talking about the variable reduction on list of high-value variable. You can use PCA, canonical correlations, clusters, factor analysis, correspondence analysis, and also you might be interested in knowing not just reduction of variable does not mean only these things. Even if you say stepwise variable selection, that's also reduction of variable. Okay, so you could use a combination of these things. More often in statistical learning, I was not facing these situations more often, because unless it is a specific factor analysis or cluster analysis, these two are not most often I faced it. These are the things most often I face, because these are relevant for cluster analysis. Even factor analysis can be used as a cluster analysis. So eventually, the thousands of variables will come down to, this is exactly what I used to do. I'm giving you notes here. Top 40 to 80 variables, I use them, and then finalize the model using test, training, validation, and testing. Okay, so that's after that we did, and as I said, I'm working on it. You'll get back your reports, inputs tonight and later tonight. And then, we kind of said, please keep these things in your perspective. These are the most important things I care for in this, reduced 10-week period project development and project, creating the project report. Now, I also mentioned I requested you to go through this material because there are three methods are commonly known on functional approaches as to data mining, KDD, SEMA, and CRISP-DM, and a comparison is written here for a review for your review. Okay. Now that is about assignment 2. Okay, so you submitted, which I'm going to give you the input later tonight. Okay. So what I'm saying is that once I give that input to you, take that input, strengthen the document with the given input, strengthen the document with the given input for your assignment 2, and then continue to build the further understanding and the material on how to do. What is that you do? Recommend the tools and techniques for data retrieval, data integration, and data transformation, and set up the train, validate, test setup process. Set up that process: train, validate, and test. Now, so you are talking about data retrieval, data integration, data transformations, and also set up, train, validate, test samples. Now, you also need to, this is where the analytic strategies come into play. What is the expected methodology and visuals that you are going to use to deliver as part of your analytics work. Okay. Of course, this expected methodology and visuals depend on what your key measurement is, right? But because you already know the key measurement, you should be able to select specific methods and ideas, from these things. Supervised algorithm means binomial classification, which is same as logistics. One version of that is logistics. And then multinomial classification, ordered multinomial, hierarchically structured classification model. I'm not sure that you heard of this. This one really means, for example, if you are an investor or not, are you an investor or not? Okay. But if you say somebody says that I'm not an investor, okay, fine. But if you are an investor, then you are hierarchically further split as do you invest in mutual funds or ETF or equity? Okay? Do you see what I'm saying? It's a kind of hierarchically tree structure. And then let's say, some people are mutual fund, they invest in mutual fund only. Some people invest in ETF. Some people might invest in both. And some people are investors in equity. And then, the equities can be, high frequency trader or not. So you see there is a hierarchical structure. I wish I had that here. I did that actually, that model in one of the consulting jobs, and I used to do a lot of hierarchically structured models. In fact, it's not that commonly taught in academic circles. You will see hierarchically structured data quite often in the marketplace, in the job. Okay, so in this case, somebody is investor. I talked about saying that somebody is invest money or not, right? So we talked about investor or not. Okay. So investor or not, and then these are all this is each one is a kind of yes or no, maybe multiple classes also possible. And then comes the next level is what type of investor or not, right? Investor not. So the next level is let's say equity versus collective like ETF versus mutual funds. Okay. And among that, again, if it is somebody is an equity investor, then we are talking about high frequency trader or not. And this is an insight that I got actually after doing a lot of work in consulting. High frequency trader or not. That is, oftentimes the hierarchically structured data come into play in our analysis. Quite often it comes more than what people are aware of, okay, or what they think they are being taught. So it falls off. No investor, yes investor. And the yes investor is equity or collective, right? ETF or mutual fund. And then if it is equity, then we are talking about high frequency trade or not. So that is what hierarchically structured data are not. There is a tricky issue here because the samples are getting split. Okay, so you are actually building at every level. You are building a binary model or maybe a multinomial model at some places. But let's say binary model, okay, which is a logistic regression. So you are building a logistic regression here, and then whatever that investor is coming out to be among the investor samples only, which is a subset of, let's say you have 10,000 samples here to start with, and then let's say 2,000 people are investors, 80% are not investors, 20% are investors, right? 10,000, okay. So and then all the 20% are, let's say 50% are not maybe even 70%, 80% are collective ETF mutual fund type investors. The remaining 20% are equity people. Among the 20%, so we are talking about probably another 10% are high frequency traders. Remaining is non-high frequency traders. So you can see that the samples are splitting here all over. So you can individually do regression classification models here, but your samples are conditional samples at every stage. So when you go back, when you actually get a new sample, you are going to run through this model, right? But you have to make some adjustments to the probabilities so that these probabilities are not overestimated at the end. Okay, so there is a small step there, but you can do that. But you have to do it. My point is you have to do it. But you will see that these are all not uncommon. In fact, I would say fairly more common than what people understand. Okay, that's one type of thing that you would not have heard of it, so I explained it. And then the ARIMA models, this is the time series data. Okay, autoregressive integrated moving average, autoregressive moving average, X models. That means these are all independent variables. Here it is purely time variable, and here it is AR integrated moving average X models. Okay, and that is these are all some classifications. This is really more about time series. And then comes the regression type models like linear model, generalized linear model, quantile regression, lasso, ridge, elastic, GAM, GLMM, all kinds of things. Okay, GLMX, Bayesian. Again, there is a hierarchically structured regression is also there. Here is the classification. Okay, ARIMA and RMAX, we can have ARIMA X. Okay, so here continuous variable. Here is the classification variable. That's the only thing. Okay, sometimes the time series variable can be classification variable. All kinds of complex models, statisticians have developed. And also, there are unsupervised algorithms we are talking about. There is PCA, factor analysis, transfer analysis. These two you might not have heard of it. How many of you heard of this one? Let me hear that out. Can you give me some input? Oh, what happened? You're all laughing. I cannot make out anything. Oh, that was 18 minutes back. Are you able to hear me? 20 minutes back, yes, it sounds like you are being. Oh, okay. Eaten by Demo. Okay, Demon's fine.
Yes, we can hear you.
Are you able to hear me?
Yes.
Or am I just talking?
No, can you hear me? Yeah, we can hear you.
Yes. Okay, cool. Okay, everybody's hearing me well, right? We can hear you now. Okay, cool. All right. So, but I asked you, how many of you heard of this DB scan and optics? Amelia
I haven't
says
heard
no.
of it.
William says no. I want to hear this because these are all input for me. What needs to be added to the course. Demi, Don, Andy. I want to hear about them. Don says, oh, none of you. What about Andy, right? Andy also here. Andy Iverson. Nobody heard of it. Man, this is interesting. Okay. All right. This is part of which course taught you the unsupervised algorithm? Which course taught you unsupervised algorithm? Can you give me the number? Anybody? Anybody? Which course taught you unsupervised algorithm? Was it 418? Not sure, but
yeah, I forget exactly which one it was.
In 2 courses, you were taught unsupervised algorithm. See. I see. Okay. All right. I will have some. Hopefully, I can communicate to people that this is actually very important. It's very powerful. It can do much better than your regular cluster analysis. Okay. You probably know hierarchical clusters and K-means. It's very common. These two. But these things will do way ahead of all kinds of stuff. So anyway, so you can do these things also. That's my point. As unsupervised algorithm. Of course, machine learning algorithm we have decision tree, random forest boosting, neural nets, recurrent network, deep learning, genetic algorithm, blah blah. Naive, Bayesian, association algorithm, sequence learning, anomaly learning, ensemble. Ensemble, of course, we don't have to. I don't have to say this specifically separately because it's all part of it here. And you can also use ensemble of combining many of these things. And then, of course, network and web location analysis, influencer targeting, viral root nodes, fraud network. All right. So there is a ton of methods, but your difficulty is going on. Jenny, I think I made up the course. I think I just made up the course. Oh, I see. All right. Okay. I think today has been a fun day. We are still retrieving from that, I guess. I will try to make sure that my system is set up better than this today. Sorry about that. Okay, so the point is you can use the many varieties of methodologies. So you have to strategize which one to use. It depends on your outcome variable and the measurement that you are using. Okay, that's the main point I want to share with you. Now, you will select, what is the right thing to do. Sequence learning is sequence learning, which is almost similar to the LSTM, which is not mentioned here. It's a little bit old, this notes. Network recurrent networks is about time series type data, and the LSTM is sequence type learning. You can use it. You can also use it in LSTM recurrent networks in context. Anomaly learning is outlier type learning about outliers. So we talked about all these things. So it also when you're doing an analytics project, you need to know what software to use and what hardware platform to use also sometimes, because not every problem can be solved with the same hardware software combination. If you are going to do this, for example, DBScan and optics, today I'm not sure whether SAS can do that. Maybe it is there. Let me just check it out. R can do it and Python can do it. Okay, SAS, DBScan. Yeah, I think it is there. I think. That's true. Yes, SAS has. Well, we don't know because some notes is there on the helps, and it may be just a question. Somebody asked, and they will simply say, "Oh, not yet there." Community question, so I have a feeling. So I'm not sure. Okay, so but nonetheless, my point is I don't use SAS anyway nowadays. I use R or Python. Okay, for doing this. So that's why I'm saying what you are going to do will determine sometimes the hardware software combination also. Okay, if you're going to do image analysis, I don't think SAS has anything. Last time and I know it. And even between R and I think both R and Python are capable of doing it, but there is more bias towards using bias means because of the need using Python, for example. Okay, so hardware software combination matters, and you have to determine what key outputs you are going to generate. Okay, that's what is going to lead you to understand about output visuals and reports. You have to commit to the types of outputs and visuals you are going to develop to your managers, because they understand, okay, you're saying all these things, Sam, what are you going to give me at the end? Okay, this is what I'm going to give at the end, right? So you have to create, for classification, if it is a decision tree, you're going to create something like this. Okay, I'm not sure that you're okay. And if it is, for example, regression model or generalized linear model, you create some kind of output like this. In the case of simple classification model, it is responders versus non-responders, but also you have some kind of a lift index and so on. Okay, you all know that. Of course, I have some additional linked notes for lift chart and so on. Sometimes the heat maps are good, but not many people like it for whatever reason. But in healthcare, it is extremely important, because clustering is important. Healthcare is still exploratory, okay, not like highly predictive. We want absolutely predictive equation and all. Many times you may not have it, especially if you're doing the bioinformatics where you are talking about genes analysis. So a combination of genes is what works out on some effects. K-means, for example, this is the kind of visual. So everything, this is the Bayesian network model. That's why it's kind of interconnected. Like it's not like a tree. Like how come this is connected to this, and so on, right? It's not like a tree, which is different. So Bayesian network models are different. So the visuals matter, including the neural network. Okay, remember that. People appreciate if you create this kind of visuals, even in the neural network context. Nowadays we could do all these things very easy. When I was doing my graduate work, my goodness, we couldn't even understand what these things are. It's all abstract, but now we have evolved to a level that we can actually explain with a lot more details like this, visually. There are software, or even R can publish this or print this. So here is another example of multivariate regression models of models how it is presented here. It's really in this case. Let me explain a little bit. So we are talking about I don't think you can read carefully, but I'll say multivariate regression model here. We are talking about the by country. Okay, this is a comparison between Brazil, Uruguay, Mexico for pooled 1 and pooled 2 regression and so on. This is another model, okay? But the point is, the outcome is a continuous rate. That's why, so you have different types of models here, the coefficient, standard errors, all those things. And the way to tabulate all these things, these are becoming some standards, so I'm kind of sharing with you. And then sometimes we also want to talk about the population distribution. For example, an example of cross-selling analysis I did, financial products visited in a web. Okay, time since sign up 17% of the people, sources signed up only 3.9%. So this kind of population distribution also helps you to understand and interpret the answers. Very, very important, okay? Because if you say something very interesting, then they will say, oh, tell me what is the distribution of this, times, they how much they spend time on the healthcare products versus the financial products since they signed up. Okay, it turns that this is twice as much as this one, and this is also almost twice. And these are all urban, rural, suburban. Demographics is zip code based is 63%. Interest is now opened at least once. In finance is 4, but it is yet sports is twice. So if you want to advertise, if you know that somebody is interested in sports, probably this is the place. In some sense, that they are interested in sports, maybe based on their demographics or some other correlated variable. Then you are better off, advertising it here, for example, right? So that they know, the manager knows it based on your insights, whatever you are going to give, he can relate it to these kinds of information. So you will ask and expect this kind of these things. Am I making sense? Okay, cool. Thanks, Amelia. You got 1 S out of 8 people. Okay. Sorry for speaking. Yeah. Okay. All right. Good. So what I'm saying, population distributions by important, variables, dimensions are very, very important. So managers will ask that kind of thing. And then, of course, project management related visuals you can create. And this is critical path method visualization. And of course, you have developed this one, all of you. So Statistical chart is very common, which tells you what are the top things that 20% of the things that that contributes to 80% effect. Kind of Pareto chart is what tells you that, right? So this is not cumulative, but when I do the cumulative function, you can see that these three things, okay, 1, 2, 3, these three things are 80%. These three things are 20%. Weather, war, slept, emergency for late arrivals as reason. Okay, traffic, childcare, public transportation, all the problems why people are coming late. I guess for the office maybe. Okay. Or slept. Okay. So the visualization is important. You select the right visuals, for right purpose, and this is a document that kind of indicates all those possibilities for you, and that is embedded here. And I have already distributed this document, okay, for assignment 3. It's the assignment 3 details and on details on sections and subsections. Finally, I want to talk to you about two things. One is how your model will be implemented. You need to describe this. Your job doesn't stop with just doing a model and then giving the model to somebody and walk away. And in fact, I want to encourage you to take ownership, make sure that it is implemented properly, and ask for the participation in the implementation team. This is very, very important. It's a politically very important, I would say, valuable suggestion for you. Because if you don't participate in the implementation, you will never get input about what happened. And also, they may not exactly implement the way you understood it, whatever that means, because it is not just a model that is built and give it to them and they know how to implement it. So please ask for that participation. That's the commonly advice I always make in every class. And what are they going to do with the analysis outputs? How are the sponsors expecting the analytics project to influence their daily operations and decision making? How will it be implemented in either campaigns or intervention? How do they plan to measure that the implementation plan is working? What kind of communication plan and teamwork needs to be in place for collaborating with the client? All these things you have to think about it. And please write something about all these things, because this is an expectation I'm putting on you that you will use similar intelligence, similar approach in your real life projects. Okay. Actually, I'm on a consulting project that it's about fraud. I'm already making these points very clear. What needs to be done when the implementation comes into play. Okay. So it is very important. You also think about this and write a section on this. Okay. This is not something graduate school teach. We are teaching in data science. It's a new field and so on. When I was a statistician, nobody talks about these things. Just we do statistical analysis and give it to somebody. Gosh. All right. Finally, another one, very important. Data science brought this up too. That is dashboard. Your work never gets recognized unless it is part of the dashboard. In fact, the dashboard started the whole conversation, if you remember. Do you recognize that? I mentioned this some time back. How do we start, what is an opportunity area? Look at the dashboard. You know where the opportunity area is. Am I making sense? That's the starting point. And I pointed out in the discussion board, if you remember. Okay? Dashboard is actually a very powerful tool for both building your relationship with the various people in the organization. These are all tough, building relationship with the organization. Dashboard is your tool. You break ice, means, you can create, talking points. Some people say water hole discussions, right? Talking points, for dashboards. I'll come to that. So it is very important. You also have a dashboard in your project. Okay. Somebody else asked what type of platform. Just use the simplest, greatest thing is Tableau. You can also use R, Shiny. But my point is Tableau is well designed as a commercial platform. I think they need to sell the product, right? So I bought a copy too. I have a personal copy of Tableau. But you get the student version, which is cheaper, better, easier for you. You don't need. Once you join a company, they'll give you a dashboard anyway. They'll give you a Tableau copy anyway. You don't have to buy. Shiny could be too cool too. Yes, of course. As I mentioned, you can use Shiny. So those are my points and for you on how to think about your assignment 3 that's coming up. It starts tomorrow maybe, but I will give my input on the assignment 2 tonight. Any questions? Thank you very much, Amelia, for asking the question. I guess you were all distracted by the happening in the front, in the early part. I'm very sorry about that. I have to shut down everything in that room, make sure that the only system is laptop or the laptop and the cell phone, so that I can make the call in the cell phone and share in the laptop. Yeah, I hope it's only smile. You didn't think that I'm really eaten by demons. All right. Any other questions, please? Please do ask. This is the best time. I always say that the present never comes back. The present time never comes back. So it's your time. We had some fun time in the beginning. It's a question time now. Anything that is out of the norm in this, in your understanding of how to do projects, let's talk about that too. I need to review and then follow the question. Sure, Ron. That's fine. I need to give you input also on this too. Assignment too. How are you feeling about this project course so far? No questions from Team 5 at this point. We'll review and let you know. That's good. How are you feeling about the projects? Are you feeling that you can do these kind of things in real life, or something is bothering you? Because many times people ask me a lot of questions. That's a good engagement in my opinion. Okay, if you don't ask questions, I don't believe that you are on board. You guys ask. You folks do ask questions, but it's not enough to make me understand that you see the depth. Maybe because assignment 2 is on my table now. I know I have to get back to you. I'm not sure. Go. There are 9 people here. So T3. I think we are progressing in a logical way, at least so far. No worries. You will be. No worries. Okay. We are going to make it work. Amelia says, Team 2 is good so far. We are looking forward to getting our hands dirty with the course modeling, and we'll reach out with questions. Excellent. So Team 3 and Team 2, how about Team 1, 4, and 5? I have 9 people here. Team 1, 4, 5, please. How is it going? How do you rate this course? Is it difficult or, moderate or breeze? I have to look into your issue tree. Most of the time people have difficulty there, issue tree, T1 is good. Okay, good. How about T4 and T5, please? Loving it. Amelia, thank you. Great synthesis, everything. Oh, thank you. Okay, synthesis, yes. That is my purpose. Actually, I have been postponing writing the book. I have enough material on this. Yeah, I hope to finish that. You are still reducing variable. That's good. Team 4 and 5, please. Any comments? Team 4 and 5. No comments, no input, no participation.
Team 5 is all set right now. I think we're in a good place.
Yes, Team 5 is good. Okay, Team 1, 2, 3. 1, 2, 3, 5. Where is 4, please? Team 5 is doing great. Okay, excellent. Team 4, please. Any input? Anything going on? You need attention. Did you ever feel by any chance that, I wish Dr. Sam is with us to answer this question when you are meeting among yourselves? Because it happened last time. And I have to meet with separately 2 teams. They had tough time, So did you feel, it looks like everybody is doing fine. Team 4, please, your input is needed. Did I hear that out? Or no? Maybe Team 4 is not here. Anybody from Team 4? Okay. All right. Team 4 is not here. Interesting. All right. But don't hesitate to reach out to me. There are no unsolvable problems. Okay. We have enough tools, enough methods, enough computing software and power. Okay. You can solve any problem. We are at that stage of evolution right now in computational methods and data science. Somebody made some sound. I heard something. That's all I have. If you don't have any questions, take this assignment 3 guidelines, and let's continue to work. Okay. It's assignment 2 review, and input is due from me, which will be done by morning tomorrow. Thank you very much, Demi. Thanks a lot, Amelia. Your participation is very much appreciated, very active. I appreciate that. Will, thank you very much for your time. Also, you have been very actively participating. Don, Amelia. Yes. Well, thanks a lot, everyone. Have a nice evening. I will edit this like before. I think I edited last week too, because the first 10 minutes has been horrible. So I will edit this and then I'll post it. Thank you very much, everyone. Good night. If you have any questions after we close it, no worries. Send me an email. Bye.